Hi, Year 12 doubles. So lovely to speak to you again, if only through the YouTube. But yeah, I'm very ambitious about how much I'd like to get done in the last 3 weeks. I think we can get pretty much certainly chapter 4 finished and chapter 5 and chapter 6 as well done. And I think we can even get chapter 7 done as well. That will leave us just two difficult chapters at the end to finish off for September, which is good. Okay, so I'm just going to take you through question 8, which is they're not too bad, these linear transformations, but I do think I hope you've had a look at the examples now, and I do think that one of their methods is significantly easier than another one. Should I take you through the difficult method first? I didn't know whether to take you through the easy one or the difficult one. Let's take you through the difficult one first. I've changed my mind already. Okay, we know this equation has these roots. Yeah, now remember the roots just the solutions to the equation. So if you like, I could say that x equals alpha or beta or gamma or delta. That value of x solves that equation. Now, let's do the awful. I just think it's longer. It's not awful. It's perfectly logical, but I just don't necessarily like it. However, there are some questions where you're kind of obliged to use method one. So it's one of those things where you do want to understand both, but you'll just be able to look at it and see, yeah, this is obviously going to take longer. So, perhaps we shouldn't do it. We've got to find, sorry, yeah, I haven't written out the question yet. We've got to find equations, find a quartic equation, sorry. Find a quartic equation with roots 3 alpha, 3 beta, 3 gamma, and 3 delta. So we've got 3 alpha, 3 beta, 3 gamma, and 3 delta. Okay, now to do this, I'm going to have to remind you about how some of the ideas in this chapter. So for any quartic, recall, for any quartic, which is of the form ax to the 4 plus bx cubed plus cx squared plus dx plus e equals 0, then we have the sum of the roots, which we denote as sum of alpha, which is just alpha plus beta plus gamma plus delta. Oh, done a D. That's just going to be minus b over a every time. The sum of the product pairs, which is where you do like alpha beta plus alpha gamma plus alpha delta. There's 6 of them, and eventually you're going to end up doing gamma delta. That's going to be c over a. The sum of the triples, alpha, beta, gamma. Well, that's where you do the triples multiplied together, and there's going to be 4 of those. Let's have the last one, beta, gamma, delta. That's minus d over a. And lastly, the product of them all times together. That's just going to equal e over a, yeah? So these are just rules which you can learn. And it always starts minus b over a, and then you just go through the doubles, the triples, and lastly, them all times together. So we're going to use that principle under method 1, which is the method I don't really like to use. Okay, so what do we know? Well, we know that the new roots, because we're dealing with a new equation here, and to make matters simpler, call your new equation's variable w, yeah? It just makes it easier to see the difference between the old equation and the new equation. So what we're going to say is that the new, if you like, the new minus b over a, well, that's going to equal the sum of all those roots. So that's going to be 3 times alpha plus beta plus gamma plus delta. But we already know what alpha plus beta plus gamma plus delta is for the old one, yeah? So if I use, I'm trying to keep this all in screen. It's tricky in color. What was minus b over a before? Well, it was minus 5 over 3. So this is actually equal to minus 5/3. So what I can do is I can say this is going to be 3 times minus 5/3. And so my new minus b over a is minus 5. What about c over a? Well, c over a, my new c over a, if I can call it that, new c over a, how are we going to work out that? Well, that would be 3 alpha times 3 beta, which is 9 alpha beta. And then we do doing 3 alpha times 3 gamma, which is 9 alpha gamma. And I hope you don't want me to do all 6 pairs here, because there's 6 ways of pairing up 4 distinct letters. I hope I can just put dot, dot, dot here and say, well, that's 9 gamma delta, because that's what you're going to do last. And so that's 9 times by, sum of alpha, 9 times by alpha beta plus alpha gamma, yeah, all the way up to gamma delta. But we already know that, don't we? We already know that because before our C over A, well, that would have been minus 4 over 3. And so what we'll be doing here is 9 times minus 4 over 3, which is minus 12. Now, what about our new D over A, minus D over A? Well, very similar, really. What we're going to do, I like seeing the, yeah, because I'm going to need that in here. So we're going to be multiplying 3 of them together now. So we're going to have product triplets, 27 alpha beta gamma dot 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 plus 27, beta gamma delta, which is 27 times by, well, let's work it out what we had before. Ooh. Okay, let's change color again. What was our minus D over A before? It was, it's going to be minus 3 over 3, which I believe is positive 3 over 3, which is 1. Yeah, so what we're going to need to be doing here is 27 times 1, which is 27. And lastly, our E over A, that's a bit easier if we work this one out first. E over A before was a third. And so what are we going to need to do here? Well, E over A, our new E over A is going to be 81 alpha beta gamma delta. And that's 81 times a third. Oh, it should be working in red now. Just trying to be consistent, which is 27 as well. Now, once you've got those, that's better. Why didn't I? Okay, once you've got those, what can we say? We can say that our new equation, let's work with W now, is going to be, well, if we set A equal to 1, and we can do this because all of these are whole numbers, if we set A equal to 1, then B will be 5, C will be minus 12, D will be minus 27, and E will be 27. What I find with this method, though, and generally this topic actually, is that it's so easy to make a sign error, so be dead careful. And now we have the answer, w to the 4 plus 5w cubed minus 12w squared minus 27w plus 27 equals 0. That should have exactly the properties we want. Basically, all the roots are trebled. Okay, why don't I like that method? Well, let's let me talk about it let me talk about method 2 really, because method 2 to me it just makes more sense. It's not that method 1 doesn't make sense, it's just quicker method 2 as well. Okay, method 2. Okay, it's just to say, okay, let's write down and let's give ourselves lots of space again and actually write everything up again. So we've got 3x to the 4 plus 5x cubed minus 4x squared minus 3x plus 1 equals 0, has roots. And I'm going to write it x equals alpha or beta or gamma or delta. Yeah, those are its roots. Those are the values which solve the equation. Well, if we want an equation with roots 3 alpha, 3 beta, 3 gamma, and 3 delta, what do we really need here? Well, let's have a look on GeoGebra. This is what this quartic looks like. Don't know why it suddenly missed off the bottom of the graph. It's weird. God knows, it's probably my computer. But yeah, if the roots are just where it hits the x-axis, we want all of those trebled. That's surely a stretch scale factor 3 in the x direction. So this is just a function transformation. How do you stretch something scale factor 3 in the x direction? Well, you replace all x's with x divided by 3. And that's why that's exactly what we're going to do. And it is to say, okay, our new equation, let's call it W. Yeah, where the variable is W. How are W and X related here? Well, clearly, W equals 3 times X because X was the original roots and W is the new roots, yeah? So what I could do is just rearrange this into W over 3 equals X and then just plug it in. My God, isn't this so much easier? You don't have to think, you just plug it in. To me, it seems like definitely the way to go with these kinds of questions. I would way prefer to do it like this. And like I say, it makes loads of sense because that's how we do a function transformation. Well, that would be a stretched scale factor 3 in the x direction, which would treble all the values of the roots. So yeah, I do like to tie it into function transformations when I'm teaching this. Okay, now it's just a case of multiplying out and simplifying. We're going to get, what is that? W to the 4 over 81 times 3, so that's W to the 4 over 27, plus 5W cubed over 27, minus 4W squared over 9, minus 3W over 3, well, that's just W, and then plus 1 equals 0. And now I'm just going to times everything by 27, so it looks nicer. W to the 4 plus 5W cubed minus, what is that, 12W squared minus 27W plus 27 equals 0. Yeah, isn't that so much easier than method 1, you know? So linear transformations, I don't think that part B is any harder. They ask us for, what about, I think it's alpha plus 1, beta plus 1, gamma plus 1, and delta plus 1. Okay, well, if all our roots suddenly increase by 1, surely that's a function transformation, 1 to the right. And how do you do that? You replace x with x minus 1. Or in other words, if you let x, remember, x is alpha, beta, gamma, and delta. X is the original roots. And if we have w being our new roots, well, then you've really got w equals x plus 1. And so, in other words, w minus 1 equals x. And that's why we're going to replace x with w minus 1. This takes a little bit longer maybe because we've got to multiply it out and simplify, but it doesn't. It's to the other method. So what do we have? 3w minus 1 plus to the power of 4 plus 5 times w minus 1 cubed minus 4 times w minus 1 squared minus 3 times w minus 1 and then plus 1 on the end equals 0. Obviously, in any of these questions, be careful. It's really easy to make an arithmetic error. I'm going to use like quick binomial theorem in my head. So w to the 4 minus 4w cubed plus 4w squared, no, 6w squared, idiot, minus 4w plus 1 plus 5 times by w cubed minus 3w squared plus 3w minus 1 minus 4 times w squared minus 2w plus 1 minus 3w plus 3 plus 1. So let's make that plus 4 equals 0. Give yourself space. It's one of those questions which goes from, one side of your A4 page to the other. Personally, when I'm simplifying that, I'm going to do the ticking approach. So 3w to the 4, dealt with that one. Okay, I'm then going to get minus 12w cubed plus 5w cubed, well, that's minus 7w cubed. Dealt with those. Cross them out or tick them or something. And then you've got 18w squared minus 15w squared, but that's 3w squared. Oh, but then we've got a minus 4w squared, so that's minus w squared. And then we got, oh, give them a tick, give them a tick, give them a tick. Minus 12w plus 15w is 3w. Plus another 8w is 11w, but minus 3w is plus 8w. And then finally, 3 minus 5 is minus 2, minus 4 is minus 6, plus 4 is minus 2. And that should give us our answer. Let me know if I've made a mistake. I think it's all right. But yeah, that's linear transformations of roots. You can have a go at the challenge question as well at the end of the exercise. It's definitely not in any way Oh, sorry, there's weird sounds in my shed. I think something's falling over. There's definitely, I've lost the thread of my thought as well. I apologize. Yeah, the challenge question in this exercise is definitely not bad. If you can just get that exercise done today, get used to it. I know these questions can get a bit samey, but make sure you get used to it. And even if you're just practicing the algebra, it's good for you. And then tomorrow, if you want to make a start on this early as well, but tomorrow we'll be looking at the mixed exercise and just summarizing these ideas. I do think this chapter is one of the difficult chapters. It's not mega difficult. It's not the hardest thing in the AS Further Maths book, but it is, it can make you think, and there are difficult ones. So yeah, keep up the hard work. And oh, before you go, I just wanted to mention, I probably should have mentioned this at the start. I'm putting into the extension classes some BMO questions from round one. I started 1993, I think it was, mainly because I've done this one before. I did it a few years back when I was practicing writing in something called LaTeX, which is what all these documents are written in. But anyway, here's the Olympiad question from 1993. Have a go at just question one. I've linked it in the extension class, which is on Google Classroom. It's all here. But I've got written solutions to all of these, except question five. So I'm going to spend some time later today trying to do that one. I had a go many years ago, and I couldn't do it. And the solution book with all the answers cost 50 quid, so I can't actually afford to find out the answer either. I want to do it on myself anyway. I always prefer doing things myself. So I don't know if I know my answer is correct to the first one because it's easily checked with a calculator, but I'm not 100% certain that my answers are correct for 2, 3, and 4. But I've got answers. Oh, 4 I'm pretty sure because I felt like it had proved it. But yeah, I'd be interested in if anybody can do question 5. But start question 1 first and then skip ahead if you want. But yeah, question 5, that's the one I can't do at the moment, and it's all in the extension classes. Remember, if you are going to be doing any extension material, you want to start looking at it this summer. This summer, that's the time to look at it. Lots of other people will if they're applying to go and do maths at top unis. Okay, well done, doubles. Keep up the hard work, and I will see you very, very soon. Bye bye.